Hello everyone and welcome to this week's lightweight Java game library 3D game tutorial, and this week we're going to be implementing support for multiple light sources. So we might as well just jump straight into the code because there's not really much explanation to do this week. We've done lighting before, and in this episode all we need to do is to organize our shaders so that they can take in information about multiple light sources instead of just one, and then run the lighting calculation for each of these light sources and then add up the results to create the final lighting. So let's start off in the Vertex Shader, and if you remember from the lighting tutorials, the Vertex Shader has the job of calculating the vector from the vertex to the light source, which it then sends off to the Fragment Shader. But now we want to have multiple light sources instead of just one, so there are going to need to be multiple 2-light vectors, one for each light source. So instead of just being one vector, we're going to make this an array of vectors, and we're going to set the size of this array to the maximum number of lights that can affect an entity at once. I've chosen a maximum of 4 lights here, but you can choose whatever number you want. Just be aware that the more lights that you use, the slower your game will run. And the light position variable also needs to be an array because of course there will be one position for each of the multiple light sources. So this line here is where we actually calculate that 2-light vector, but now we need to do that 4 times, once for each light source. And we can do that using a for loop, and this works just the same way as it would in Java. So I'm going to loop round this bit of code 4 times, and each time we're going to calculate the 2-light vector for each of the light sources. So 2-light vector I equals light position I minus the world position of the vertex. So we have to do the same kind of thing in the Fragment Shader. There are now going to be 4 2-light vectors coming into the Fragment Shader, so make that an array of size 4 or whatever size you set the maximum lights to. Same for light color, there's now going to be one for each light source. And now in the code we need to run the lighting calculation 4 times, so find all the code that has something to do with light sources, like all of this stuff. This is to do with a camera, so we don't need to run that 4 times, so take that out and put it up here at the top so it's not part of the lighting calculation. But all this stuff here is to do with the lighting calculation, so all of that needs to go together because we need to run all of this 4 times. I'm just going to take out the diffuse calculation and put that at the bottom, so we have the diffuse and final specular at the bottom of the calculation there. But all of this is going to be run 4 times, once for each light source. So create your for loop and run that however many times, however many lights you have. And that's going to go over all of this code because all of this is lighting calculation code, so it all needs to be run 4 times. And then you've just got to put 2-light vector I up the top there, and then 2 times light color I, so once there and once here. So what the shader is doing now is calculating the diffuse lighting and specular lighting caused by each of the light sources, but at the moment we're not doing anything with those final lighting values for each light source. What we need to do is we need to get the sum of the diffuse lighting and the sum of the specular lighting caused by each of the light sources, so we're going to need to have a total diffuse and total specular value outside of the for loop. And we'll just initialize these total variables to 0 to start with, but then every loop of the for loop, for every light source, we're going to add the diffuse lighting caused by that light source to the total diffuse, and we're going to do exactly the same with the total specular. So we basically keep a running total of the lighting caused by the light sources. So we now need to substitute these total variables in to the out color calculation, so put in the total diffuse there, and the total specular goes in here. Then there's one last thing to do with ambient lighting. We're now calculating the ambient lighting 4 times, so that's going to add up and be a little brighter than we need it to be. So let's take that out. We're going to set that to 0 there, and we're going to add in the ambient lighting calculation outside the for loop. So here we're going to make sure that the total diffuse never goes below 0.2, just to make sure that any part of the model never goes completely dark. because that doesn't look very good in the game. So in the static shader, before we go any further, let's set up an int constant, which is going to hold the maximum number of lights, which, as I said, I have set to 4. So at this point we would usually get the location of the uniforms and store them into int variables like these here, but this time it's a little bit different because we don't just have one light position and one light color uniform, we have a whole array of them, and each element in these uniform arrays has its own location. So we need to get the location of each element in the light position uniform array and each element in the light color uniform array, and we'll store these locations into arrays of ints. So we'll have an array of light position uniform locations and an array of light color uniform locations. So let's now actually get the location of these uniform array elements. So delete the old code that we used to get the location of those uniforms, because we don't need that anymore. The first thing we need to do though is to actually initialize these int arrays, and we're going to set them to the size of the maximum number of lights, whatever value you chose for that. So do that for the light position location array and the light color location array. Now what we're going to do is we're going to loop round 4 times in my case, and we're going to get the location of each of the elements in those uniform arrays, and then we're going to store them into these int arrays. So I'll do that first for the light position uniform array, going to get the location of each element. And to do that we can still use the getUniformLocation method, and the name of the uniform is still light position, but to get the location of an element you would do like that to get the location of element 0 or to get location of element 1, but we want to get the location of element I, so we come out of the double quotes and we do +I plus, and then back in the double quotes we close the square bracket. So that will get the location of each of the elements in the uniform array, and we have to do the same of course for the light colors. So location light color I equals get uniform location light color, open square bracket I, close square bracket. So we also need to change this method here, the load light method. We're going to change this to be called load lights, because this is now going to take in a list of lights, and we're going to call this list lights. So let's delete the old code that we have in here, and we need to load up the information for 4 lights. So I'm going to create a for loop which is going to loop around 4 times, or however many times you've set your max lights to. And it needs to load up the information for 4 lights, but we don't know if there are 4 lights in this list of lights. There might only be 2 lights in your scene. So we'll first check, is I less than lights.size, because that will tell us if there are any lights left to load up. So if there are, then we can load up the information about light I. So first we'll load up the position of light I, and we're going to load that up to the ith element in the light position array, the light position uniform array, and then we'll just load up that position of light I. And we of course have to do this the same for the color of light I. So we'll load up the color of the ith light in the list to element I in the light color uniform array. So make sure you change that to light color and light.getI.getColor. But if there aren't any lights left in that list, then we're just going to load up some empty information to the shaders, because we need to make sure that there is some information in those arrays. So we're just going to load up a 0, 0, 0 vector for the light position, and also a 0, 0, 0 vector for the light color. So they're basically empty lights. So all this method does is to take in a list of lights in the scene, and this could be any number of lights, but it just loads up the first 4 lights in the list to those uniforms in the shaders. And if there are less than 4 lights in the list, then it just loads up a load of zeros to fill those extra spaces in the uniform arrays. So we're almost done now. We need to go into the master renderer though, because this only takes in 1 light at the moment, and we need to change it so that the render method takes in a list of lights instead of just 1 sun. Then we can put these lights into the shader.load lights method, so change that to load lights. But it is at this point that you'll realise that we can't load up a list of lights to the terrain shader because we've only implemented the multiple light support in the entity shader code. So at this point you need to do the whole tutorial again and do exactly the same stuff, exactly the same code, but this time you have to do it for the terrain vertex shader code, the terrain fragment shader, and then finally the terrain shader class. So hopefully you'll eventually get back to this point in the tutorial where you will now be able to load up the list of lights to the terrain shader. So do that. And once you've done that, you can go into the main game loop, go to where you usually set up your light, and now you need to create a list of lights, and you can add your original light to that list, but you can now also add some new lights with their own positions and their own colours, and you'll see here that I've made my colours very bright because I want to be able to see what's going on. Also down here in the while loop, we need to change the render method to take in the list of lights instead of just one light, and then we can go ahead and run that, and you'll see that everything is looking extremely bright and colourful. I think we've got blue light coming from this direction, and then the other side we've got some red light coming in, and from this direction we've got the original bright white light from the sun coming in. So it's all looking very colourful, but you'll notice that the brightness of the light is the same everywhere in the world. When you add other light sources like lamps or torches into your world, you'd probably want them to only light up the terrain and objects that are near to the light source, and for the light to be less bright the further away you are from it. To do this, we need to add an attenuation calculation into the shaders, but we're going to leave that until next time. Also, you're probably going to want to have more than 4 lights in your whole game, and that's absolutely fine. You can have an unlimited number of lights in your world, it's just that only a limited number can be used for the lighting in the scene at any one time. But if you just sort your list of lights by distance from the camera, then you'll always have the nearest 4 lights to the camera being used to light the scene. Also, if you want to optimize the system a bit, then you might consider only loading up the information about the lights to the shaders when the information changes. If your light never changes position or color, then it's really unnecessary to refresh the information in the shaders. You can just load it up once to start with. So that is it for this week. Thank you guys very much for watching. If you haven't seen yesterday's devlog yet, then do give that a watch. A link to that is on the screen now, and this week I was working on adding particle effects and sound effects to the animations. Next week in the tutorials we're going to be doing the attenuation calculations so that we can have things like lamps in our 3D world. But yeah, thank you guys very much for watching this video. Do subscribe if you haven't already. Have a fantastic week, and I will see you all next time.